Panning the audience. 1, 2, 3, 4, and 5. And you're good. Go ahead.
All right, everybody, thank you for joining me today. My name is Jason Durrett, and I'm here to present my informative speech on workplace safety, lockout, tagout in an automation setting. I've been turning wrenches and working around heavy industrial machinery for over 30 years. In that time, I've seen a lot of great things built, but I've also seen a safety video of someone receiving a near fatal dose of electricity. He lost an arm because someone flipped the breaker switch while he had his hands deep inside a transformer enclosure. That accident happened in a split second, and it changed his life forever. Today, I'm here to inform you about the most critical safety procedure on any job, the lockout-tagout protocol, commonly known as LOTO. If you have to work in a factory, or you don't have to work in a factory to need this information, whether you are wiring a new outlet in your kitchen, fixing a jammed snowblower, or managing a crew on a construction site, understanding how to kill and secure a power source can quite literally save your life or limbs. As an automation engineering tech and a previous SCADA technician, I've spent thousands of hours programming, troubleshooting, and calibrating machinery and the controllers that run them. In addition to my real-world experience, I have read and completed almost all of the assignments for my Comm 101 Understanding Human Communication course, this book right here. This has taught me how to effectively communicate these complex safety processes to the rest of my team. Today, we're going to look at three main things. Number one, what is lockout tagout? What it really means inside of a high voltage electrical control panel. Number two, the practical step-by-step procedure to safely shut down, lock, and verify that a control panel or machine has zero stored energy. And number three, the harsh reality and life-altering consequences of what happens when a technician gets lazy and cuts corners to save 5 minutes. First, let's start by breaking down exactly what lockout tagout means in the trades. So what is lockout tagout? According to OSHA, Title 29, CFR 1910.147, this right here, lockout tagout refers to a specific practices and procedures to safeguard employees from a couple of things. First off, the unexpected energization or startup of machinery and equipment. And second, the release of hazardous energy during service or maintenance activities. As you can see on this poster, it provides a physical barrier from danger. With the different types of hazardous energy, we aren't just talking about raw electricity. Industrial equipment contains multiple forms of stored energy that can be dangerous, damaging to equipment. One is electrical. That's the most obvious. High voltage currents running from and to heavy-duty factory machinery. Another is pneumatic, pressurized air lines that can cycle a cylinder. Ones like hydraulic, pressurized fluid lines that drive heavy presses, and even mechanical or gravitational, heavy physical components held up by tension that could crash down if released. Now, if we understand the types of dangerous energy, let's walk through the exact steps to secure a machine using lockout tagout. The standard lockout tagout safety protocol consists of 8 crucial steps designed to ensure electrical equipment is completely de-energized before any work or maintenance begins. Number 1, turn off the equipment off using the regular on-off switch to interrupt the load current. Number 2, open all disconnect switches or circuit breakers feeding the electrical power to the equipment, like the one shown here in this breaker panel. Number 3, visually confirm, also in this breaker panel, that all poles are disconnected switches are indeed open. Number 4, attempt to restart the equipment as your first physical confirmation that the power has been shut off. If you flip it on and off, there's no obvious sign of power, it's off. That's the first step saying that it's okay. Number 5, attach locks and tags to prevent disconnecting switches from being reclosed by somebody else. If there is no lockable disconnect means available, you must open and tag 2 or more redundant disconnects. That's done here. We have it actually physically locked out with a padlock, and we have our lockout tagout tag signifying that something's going on, you shouldn't mess with it. Number 6, Confirm the proper operation of your voltage meter by testing it against a known live voltage source. Make sure that you are getting a reading on your meter. Number 7, test for dangerous voltage between all relevant conductors, especially those you could physically contact. This includes measuring between pairs of phase conductors in a polyphase system, as well as between each phase conductor and earth ground. Number 8, confirm the proper operation of your voltage meter again against a known source to ensure your meter didn't fail during that test and showing you a false 0 reading. These steps might seem redundant, but they are also designed to protect against hidden failures. Verification of the voltage meter in steps 8 and 6 is critical because test leads can easily fail open. If they do, the meter probing a live circuit will read 0 volts, creating a deadly false sense of security. Following these 8 steps seems simple on paper, but failing to execute them has a massive tragic cost. The first is workplace injuries and fatalities. According to the Bureau of Labor Statistics, compliance with the LOTO standard prevents an estimated 120 fatalities and 50,000 injuries each year in the United States alone. Also, if a machine unexpectedly cycles, injuries usually result in catastrophic amputations, severe electrical burns, or instant death. The second cost, of course, is operational downtime and liability. A single lockout tagout incident leads to immediate OSHA investigations, massive fines, often exceeding $100,000 per violation, and critical production downtime. Now, as we wrap up today, let's review why these procedures are the foundation of our work. I appreciate you all giving an old tech the time to talk about safety protocol that means a great deal to me and the guys I work with on the floor. Today, we have reached our goals of understanding, first, what is the lockout tagout procedure? Second, how to properly execute the 8 steps of isolation and lock application. And third, why cutting corners to save a few minutes is never worth your life. Look at my work boots, my clear safety glasses, my safety vest. These aren't just props, these are my shield. The next time you grab your toolbox to fix a jammed machine, remember how easy it is to lose a hand. Cut the power, tag the source, verify it's dead, and make sure you go home to your family in one piece. Does anybody have any questions about lockout tagout?
What other industries would this happen in?
So many. Anything that has to do with electrical machinery. I, for one, worked at the irrigation district. We would have to lock out the pedestals and physically the valves to make sure water didn't rush down a line that the guys were in fixing in a tunnel to prevent them from drowning. So, anybody else have any questions? Okay. Very good.
All right, last pan of the audience. 1, 2, 3, 4, and 5.